Okay, so last time that we were together, we were talking about differentiation using our rules, and we just had a look at some basic expressions with one term, sometimes with more than one term, etc., etc. So what I wanted to focus on today is what we do when functions have more than one term, and how we need to get rid of brackets, divide lines, and root signs in order to find the derivative of any function expression that we are given. Please pay particular attention to your notation the whole way through. You will be penalized in exams and tests if you write dy over dx the whole way through and you actually haven't taken the derivative yet, or if you drop your dx notation too soon, etc., etc. Okay, so please, it's not just a matter of finding the derivative, it's also how you set it out is really important. Okay, and I will try to emphasize that each step of the way. Okay, so always get your terms to a form which allows you to apply the rules of differentiating to each term. So what I mean by that is that you are writing each term, okay, sign, number, variable in the numerator with your exponent, okay, and then you can apply your power rule to every single term. Okay, so just to illustrate what I mean by that, for example, if you are given an expression like this that has 3 terms in it and they asked us to differentiate, each term has been written sign, number, variable. Okay, so there's no manipulating that needs to take place, so we can go ahead and simply find the first derivative by applying the power rule. So remember, when we apply the power rule, we are multiplying the exponent with the coefficient. In this case, it is 1. So we would say 4 times 1 is 4. And then we're going to take 1 away from our exponent and we're going to get 3. And we're going to do that to each term. Okay, so the next term is going to be plus 6. And then if you recall, whenever I find the derivative of a constant, it is equal to 0. Okay. Let's go and have a look at something a little bit more complicated than this. Okay, so let's talk about what happens when we remove brackets. So either they can expect us to remove brackets by doing FOIL, or they can expect us to remove brackets by distribution. Okay, so distribution or FOIL. It just depends on what they end up giving us. All right, so if we have a look at example number 3, this is FOIL. Okay, please look at my notation as well. All right, so I am not differentiating. So I'm writing f of x and not f prime x. I first want to write my brackets out, because then I square a binomial, I've got FOIL, and now I'm going to do my FOIL, and I'm going to end up with 16x squared minus 24x plus 9. Do you see how I've kept my f of x notation? Now, when I want to differentiate, I'm going to write f prime x, and now I'm going to apply the power rule to every single term. So 2 times 16 is going to leave me with 32. And then I'm going to take 1 away from my exponent. And it's the same with my next term. I'm going to say this invisible 1 times negative 24 is negative 24. And I'm going to take 1 away. And then, of course, my derivative of my constant is going to end up becoming 0. Okay, so a question like this, there would only be worth 2 marks. There would be 1 mark for removing the brackets. Generally, there's 1 mark on each term, but I think at matric level, they would probably just give 1 mark for the correct answer. Okay, so what I want to do, sorry, I should have done this earlier, is I want to go down here and I want to grab this particular question, sorry, and pop this over here as well. Okay, so what I'd like you guys to try now is 2 of the following questions. All right, question A is the easiest. Question G and question X are a little bit more difficult, and the most difficult one would be question N. All right, so I want you to try 2 of the following, and then we're going to talk about our answers. Okay, try the more difficult questions. Question A is very simple. It's not going to be worth many marks. You really want to try to be able to do G or X or N. Okay, off you go, Matrix. And please ask Yolanda or I if you are stuck on anything.
We are definitely here to assist, guys. Let's go. Let's do this. It's go Matrix, and when you're done, you can just say on the comments that you're done so we can see that you are done.
Yes.
I love calculus. It's my most favorite content in Matrix. It gives you that satisfactory. My English is running away after getting it right. I see the Chokoko is like, yes, me too.
Oh,
Simpiwe, no stress, no stress. Just try on what's on the board. But luckily for you, Teacher Lee is here to help all of us out.
okay, so we've got to remove the brackets, we've got to remove the radicals, and we've got to remove the divide lines. Okay, and then we're going to differentiate what's left over. Okay, so we spoke last time about what happens when we remove radicals and divide lines. The only thing that's new now is when we remove brackets, but you know how to do that because you know how to distribute and you know how to do FOIL. Okay. Okay, so remember, you're going to try 2 questions. And when you're done, just put done into the chat. And then we're going to go through all our answers together.
Yes, guys. Nice. Zandile is like, I'm done.
Good. Well done, Zandile.
Yeah. Guys, the weather is so cold in Joburg. I promise you, the next boot camp on Saturday, We're coming with our pajamas on Zoom and some nice tea or anything that you like.
Or hot chocolate.
Or hot chocolate. Yes. In our blankie with a paper and a pen and a calculator. So cold. Tongi, for some reason I can't mute you. So please make sure that you are muted. Thank you so much. I hope everybody is not trying to do every single question. So when you are done
No,
with
just
two,
two. Just
yes,
two.
just say you are done on the chart so we can go. So you can just say done like this is an indication for teacher Lienai to see that you are done. Kando, it's okay. Kamogelo is done.
Tanda, what's you struggling with? Which one are you trying?
So, ma'am, I'm trying to do in, and I got through the first part of like, wait, I'm confused on whether I should solve the brackets first before expanding or expand and then solve the brackets.
So A is, were you here when I did the example?
Not really, ma'am. I came in.
Oh, okay. You came late. Okay. All right. So all you have to do is remove the brackets doing FOIL and then apply the power term to every single term. Okay, so what's important is your notation as well. You've got to keep your dx notation whilst you are removing the brackets. So you're going to do FOIL. So 2x times x is going to give you 2x squared. 2x times 4 is going to give you plus 8x. Then your inner terms, that's going to give you minus 3x. And then your last term is going to give you minus 12. Collect your like terms together, keeping your dx notation because you're not taking the derivative just yet. That gives you 2x squared plus 5x minus 12. Now you're ready to apply your power rule to every single term. So what should you write? What should you write now?
With the power rule, the first term is going to be 4x.
Good. And
The
the second
term is going to be plus 5. And
Lovely.
then the last one is equal to 0.
Beautiful. There you go. Okay, 100%. So you did that one perfectly. Okay, good job. Well done.
Okay,
Okay,
thank
and
you,
then
ma'am.
no problem. And then again, as I was saying to the others, just mind your notation the whole way through. When you are getting rid of brackets, root signs, and divide lines, you are not taking the derivative. So you have to keep your original notation until the line where you actually apply your power rule. Okay, anybody did G who wants to tell us how they did G, please? Any volunteers for G? Any volunteers for G?
Let's go. Before I pick anyone, I'll do any, mini, money, more. I'm joking, guys. Let's do this, guys. Anyone who has tried it, remember that teacher Lee and I are here to help you either way. So if you get stuck, there we go. Thank you, Kamogelo.
Cool, Kamogelo, go for it. All yours.
Hi, ma'am.
Hi, Kamogelo.
I actually have a question regarding A.
Oh, okay.
So you see, you did the first step and the second step, then got your answer.
Uh-huh.
You know what I did? I did the expansion.
Mm-hmm.
So in an exam, do you think like I should leave it out? Like I should leave the expansion out, or I should just write it down?
You mean no? So in a test or an exam, what you would have to show the second line and the last line. Okay, so if you didn't do the first line, that's not the end of the world, but you have to have the second line and the last line. So what I put brackets around the blue, you'd have to have. Okay.
All right. Thank
All
you,
right.
ma'am.
No problem. Zandile, you're applying your power rule. 2 times 2 is 4. Okay, remember your power rule, you're multiplying your coefficient, okay, with your exponent, and then you're taking 1 away from your exponent. Okay. All right. Anybody want to try G first?
Hi, ma'am. Can I do G?
Yeah, go for it.
So, ma'am, I first changed root x into x to the power of a half.
Sure.
And then I multiplied out two brackets.
All right. So in other words, you had that, right?
Yes, ma'am.
Cool. All right. Keep going.
And then I multiplied two brackets out.
Okay. And what did you end up with?
X to the power of 4
Uh-huh.
minus 2x plus x.
Okay, now let's just double check that you haven't made any mistakes here. I agree with the x to the power of 4. Then when you've got x squared, so now we're talking about your outer terms, when you multiply like bases, you add your exponents. So you should have had to the power of 5 over 2 here. Okay.
Wait, ma'am, can you explain that?
Can I explain that to you? Sure, no problem. Okay, if I went a little bit too fast there. Okay, so let's just go back to this. Okay, so you get, we're doing this now. We're multiplying this term here with that term over there, right? So when we multiply x squared with minus x to the power of half, we're going to end up with minus 1 x to the power of, when you multiply like bases, you add your exponents. So it's 2 plus a half. So 2 plus a half is 2.5, which is 5 over 2. Then when you multiply your inners, you'd have the same thing, 5 over 2. And then over here, you'd have plus x, like so. And then that means that you would end up with x to the power of 4 minus 2x to the power of 5 over 2 plus x. Does that make more sense now?
Yes, ma'am.
Okie dokes. All right.
And
Okay, no problem. So based off of this over here, now we are ready to apply our power rule. So we're going to drop the dx, we're going to drop the square brackets, and we're going to say 4 times 1 is 4, take 1 away from the 4, and we're going to end up with 3. 5 over 2 times negative 2 is going to leave us with negative 5. X, and then we're going to take 1 away, so that'll leave us with 3 over 2 plus 1 would be our last term. Okay, so in a question like this, there would be a mark for for getting rid of the root, so writing the x to the half. There would be a mark for getting rid of your brackets, so foiling correctly. And then generally there's a mark on each term as well. I don't know whether this would be out of as much as 5, maybe a mark on that term and a mark, I don't know. 5 seems like quite a lot for G, but anyway.
Ma'am,
That's
I
the
don't quite
general idea.
understand how we get the answer.
What answer don't you understand? Are you talking about 4x cubed minus 5x to the power of 3 over 2 plus 1? You mean that answer?
Yes, ma'am.
Okay, you're applying the power rule. You're differentiating. So you are multiplying the exponent with the coefficient. The coefficient is 1. 4 times 1 is 4. Then you've got to take 1 away from the exponent. Okay, and then it's the same thing with the second term. You're taking 5 over 2, you're multiplying it with negative 2. That's how you get negative 5. Then you're taking 1 away from the coefficient. Same with the last one. You're taking 1, you're multiplying it by 1, and then you're taking 1 away. All right, Cynthia, I hope you heard that. I just explained again how you would apply the power rule to every single term. Are there any other questions? Can we move on to question X? Kamgelo?
Ma'am,
Mm,
on the second step, we said x squared multiplied by x squared, which gave us x to the exponent 4, right?
yes.
And then we said x squared multiplied by x
Negative x to the power of a half.
Oh, all right. Thank you. That's where my
Okay.
mistake came
All
in.
right, that's fine.
Thank
Okay,
you.
no problem. Any other questions, Matrix? Okay, so how did I get x to the power of a half? Zwanaka, when you have root x, that's what it means, isn't it? Okay, so root x, there's an invisible 2 here and there's invisible 1 there. So you're going to write your root with a rational exponent. Just like if you had the cube root of x to the power of 7, you would write that as x to the power of 7 over 3. I don't know if you remember, this was our very first lesson together. We spoke about removing the roots and writing them with rational exponents. Okay, so that's a skill that we have to be able to have if we want to differentiate. Okay, don't know if you guys remember me saying that the guy at the bottom gets kicked to the outside of the party. So that's how you can remember which number goes at the bottom and which one goes at the top. Okay. All righty. Katleho, do you want to ask a question? Or do you want to do X for us?
No, ma'am. I just want to try number N, not X, ma'am.
Sure. Okay, that's fine. Katleho, N is all yours. Why don't you do N now while I've got you? It doesn't matter if we don't do it in order, it doesn't matter. Okay, go for it. How did you do N? Tell me what you wrote.
Okay, so ma'am, first I applied the rules. I don't necessarily remember what is the name of the rules.
Okay.
Ma'am, what is this? Square root x over 2, ma'am. It's the same as 1 over 2 x to the power of half, ma'am.
Lovely. I love the way you've done that all in one step. That's beautiful. Good job. Okay, keep going.
Plus 2x to the power of half.
Negative half.
Oh, okay, ma'am.
Okay. Katleho, why is it negative half and not positive half?
The x was the denominator, ma'am, not the numerator.
Good. Well done. Okay, that's perfect. Okay, so now, based off of that, would you be able to do the next step for me? Because obviously what we're going to do is we're going to multiply this bracket that you've just given me. We're going to be multiplying it by itself, right?
No, ma'am, because I did it with, like, I was adding the numbers in
Okay.
the bracket. Now that
All
the
right.
experiment is different, I can't do it
You've
anymore,
obviously
ma'am.
you've got a different answer now. That's fine. Okay, well done. Okay. All right, let's do the next bit together, everybody. Okay, so now we're going to be doing FOIL. All right, so the first thing that I'm doing is the firsts. First term with first term. So a half times a half is a quarter. When you multiply like bases, you add your exponents. So a half plus a half is 1. Not that you need to write the 1 there, but I'm just putting it there first. Now we're going to do the outers. Okay, so now a half times 2 is 1. So I'll just put the 1 in front of the x. When I multiply like bases, I add my exponents. Okay, so now a half plus a negative half gives me to the power of 1. I forgot the x. Where did I forget the x?
At the last term, you know the last term inside the two brackets? It's
Oh,
2x to the power
man,
negative half.
sorry. That's better, isn't it? Okay. All right. So, where were we? Okay. Okay, so a half times 2 will leave us with 1. And then when we multiply like bases, we add our exponents. Okay, so now there's a problem, right? Because, well, not a problem, but a half plus a negative half is going to leave me with an exponent of 0. Okay, if I've got a 0 exponent, it means the exponent on my variable is 0, so my answer is just going to be 1. Okay, when I do that. Same thing with the middle term over here. I'm just going to have 1. There's not actually going to be an x in it at all. Okay, and then when I do last times last like that, I'm going to end up with plus 4x to the power of negative half minus another half. That would leave me with negative 1. So now when I collect my like terms together, I'm going to have 1 over 4x plus 2 plus 4x to the power of negative 1. And now I can apply my power rule. I'm going to drop my dx. I'm going to drop my hard brackets. I'm going to take this invisible 1, multiply it by a quarter, take 1 away from my exponent. So now I've got a 0 exponent on my variable. Plus 2 would become 0. A negative times a positive is a negative, and that would give me 4x to the power of negative 2. Okay, so now someone was asking if I could go back. Screenshot of X. I'm going to go and do question X now. Okay, we haven't done question X yet there. Okay, so screenshots, everybody. And now, are there any questions?
Ma'am?
Yes, Veloshan, you do. Yes, Tikhvatso.
Ma'am, do we leave the answer just the way it is, or do we have to change the exponent and put it like the negative 4, or to the power of 2?
No, you don't. So Veloshan in the chat is asking the same question as you. So good question, both of you. It's funny because in grade 9, 10, and 11, we make you write all negative exponents as positive exponents. And in matric, in calculus, you're allowed to leave your answer with a negative exponent. So yeah, I wouldn't even bother going back and writing it with a positive exponent. You're just wasting your time. Okay, rather move on. Okay.
Okay, thank you, ma'am.
No problem. All right.
Nice, guys. Well
Nice,
done.
guys. Well done, everybody. Okay, so hang on, Nolatando, you're asking. Okay, maybe you can help Masike.
Okay.
Yolanda.
Yes.
Nolatando, how did you get the -2 by the -4x? Okay, so Nolatando, your question in the chat, remember you've got to take 1 away from your exponent when you apply your power rule. So if you've got an exponent of -1 and you take 1 away, then it's -1 minus another 1, which is where the -2 comes from. Okay. Good question. Where would the mark allocation be? Okay, so there's always going to be a mark for removing the roots. Okay, so in other words, that you've written root x is x to the power of 1 over 2, you'll get a mark for that. I think in this situation over here, there would definitely be a mark for the x to the power of -1 over 2 as well. An accuracy on foiling it out correctly, and then an accuracy on each term. Okay. No problem. Okie dokes. Let's go on and have a look at question X now. These ones often give us problems.
Ma'am, can I do a X with?
Yeah, go for it. Go for it. Go for it. Awesome. I'm so glad to have someone else do it instead of you having to listen to my voice. Okay, lovely. What did you write?
So I changed the root x to x to the power of half.
Lovely.
And I changed the 1 over 2x to the power of 3 to half x
Yes.
negative
Yes.
3.
Lovely. Beautiful. Well done. Keep going.
And below that, I have x to the power of 7 over 2.
Okay, nice. Good job.
Plus a half.
Mm-hmm.
X to the power of negative 5 over 2.
Excellent. Well done. Very good. Keep going.
Below that, I have 7 to the power of 7 over 2.
Uh-huh.
And then an x to the power of 5 over 2.
Sorry, I just made a bit of a mess there. X to the power of 5 over 2. Lovely. Good job. Well done.
Minus 5 over 4.
5 over 4. Uh-huh.
Yeah, that's the derivative of.
Okay, and then what did you do to your exponent? So you've multiplied your exponent by your coefficient. Remember, you've got to take 1 away. So your exponent here on your last term is going to be x to the power of?
What I didn't write.
You should have ended up with that. Negative 7 over 2. Does that make sense to you?
Yes, ma'am.
Okie dokes, lovely. All right. Good job. Well done. Okay, so again, there's going to be a mark for writing root x as x to the power of a half. And I think in this case, probably also a mark for taking the x to the power of 3 into the numerator and changing the sign. Then we got rid of the brackets. Remember, when we multiply like bases, we add our exponents. So that's where x to the power of 7 over 2 comes from. And it's also where x to the power of minus 5 over 2 comes from. And then in our last step, so an accuracy mark on removing the brackets correctly. And then again, there would be a mark on each term over here. Okay, so Neo and Katlejo, what are you struggling with in question X? So we've spoken about the root x before and why that would be x to the power of a half. Its distribution. So you're multiplying x to the power of a half with x to the power of 3. When you multiply like bases, you add your exponents. So 3 plus a half is 7 over 2. Okay, and then 1 times a half is a half. When you multiply like bases, you add your exponents. So when you add a half to negative 3, you get minus 2.5. So the brackets are gone. And now you're dropping the d over dx, you're dropping the hard bracket, and you're applying your power rule. So you're multiplying your exponent by your coefficient, and then taking 1 away from your exponent, and you're doing that to each term. Okay. All right, matrix. Let's move on and talk about what would happen if we have a monomial denominator. Okay, so when you have got a monomial denominator, it's like having this, for example. Let's say you had 1 plus 2 plus 3, and all of that was over 5. You can write that as 3 separate fractions. You can write it as 1 over 5 plus 2 over 5 plus 3 over 5. And that's what we're going to do here, right? So when you've got a monomial denominator, you need to split the numerator over the denominator. So that's your first step. After you have split the numerator over the denominator, you are going to use your exponent rules to cancel down, okay, or to simplify each term. So as follows, this is what I mean, okay? So equals dx, first step is to write x squared over 2x squared. Next one is to write minus x over 2x squared, and then to write minus 6 over 2x squared. Okay, again, I'm keeping my dx in my square brackets because I'm not differentiating. I'm still just getting my statement ready for differentiation. So remember, at the top, there's an invisible 1 there. There's an invisible 1 over there as well. So I'm going to write that as 1 over 2 because x squared divided by x squared is 1. So it's just 1 over 2. Then second one, I've got my half separated. X divided by x squared would leave me with x to the power of -1 when I divide like bases. I subtract my exponents. And then with the last term, 6 divided by 2 would leave me with 3. And I'm going to take my x squared to the numerator, and I've got to remember to change its sign. Okay, so all of this is very repetitive. I just keep doing the same thing over and over and over again. All right, let's move these guys out the way. Okay, so now I've written each term, sign, number, variable. Now I'm ready to drop my dx and my hard bracket, and I'm going to apply the derivative to every term. So the derivative of any constant is 0. Here I've got a negative times a negative is a positive. 1 times a half is a half. And then I've got to take 1 away from my exponent. Same thing with my third and final term. Negative times a negative is a positive. 3 times 2 is 6. I've got to take 1 away from my exponent. Okay, so here, matrix, there's going to be a mark for splitting, simplifying it accurately, and a mark on each term. Okay, any questions?
We're just having Eve asking us to go back to what we did so she can take a screenshot.
Okay, to which question?
Question X, the one that we did
Okay.
before.
All right, that's fine. Okay, so this is for you, Eve. There you go. It's the green one in the middle. Take a screenshot. And then we're moving on. Okay, you should be done with your screenshot by now. Okay, so you guys are going to have an opportunity to practice these. There you go. So question E is a bit easier. The other question is a little bit more difficult. All right, so just do one, please, matrix. Either the easy one, or you can do the one that's a bit harder. Put a red dot there.
Ma'am, just to be sure, when you divide exponents, you minus instead of like add, right?
Correct, correct. So when you multiply like bases, you add your exponents. When you divide like bases, you subtract your exponents. Excuse me.
Give it a try, guys. The green and the red. Let's go. Y'all can do it. That when you're done, you need to put on the charts that you're done so we can be aware that you are done.
Yes. Cool. Nice. Cool, guys. Nice, everybody. Okay, who would like to do the one on the left? Anyone would like to do the one on the left, one with the T's in it? Any takers?
Going once, going twice. Remember, it's your time to shine, my people. Let's do this.
Absolutely. So nice to hear your voices instead of mine. Who wants to do the one on
Definitely
the
will
left?
help you if you get stuck.
Of course.
Let's go, my people. To people who have said they're done, Offense, would you like? Oh, Donnell has rescued Offense. Okay, Donnell, let's go for it. I was about to pick on Offense.
Hi, can you hear me?
Yes, we can hear you, Donnell. Go for it.
So I started off by splitting the top part into its denominators. So it's t to the power of 3 divided by t minus t to the power of 2 divided by t plus 1 divided by t.
Oopsie. There we go. Lovely. Cool. Keep going.
So then I went on and said, I took out the denominators, so it gave me t squared minus t plus t to the power of negative 1.
Very nice, Donnell. Lovely. Okay, and now?
And then my final answer was 2t minus 1 minus t to the power of negative 2.
Beautiful. Okay, well done, Donnell. All right, very good. So if you had done as Donnell has done here, it would have been absolutely perfect. Don't forget about your notation. It's only in the very last line where we applied our derivative that we would drop our dt and our square brackets. Okay, so good. Mark for splitting. Accuracy on simplifying it here. And I think this is quite an easy one. So there would just be an accuracy on the answer like that. Good, Tundo. Well done. Natalie, would you like to do the red one for us?
I can, ma'am, but my explaining skills are very bad. So you guys can
Natalie, of course, go for it. We're really glad to be able to hear your voice, Natalie. I don't think I've ever spoken to you before. Is this the first time?
It is, ma'am, but I'm always in the comments. So
that's okay. That's okay. We love hearing your voice. Okay, go for it. You tell me what you wrote and I'll put it on the screen.
Okay, first what I did was I splitted it. So I said y equals 2x squared over x a half.
All right, cool.
Minus x to the power of a half over x to the power of a half plus 5 over x to the power of a half.
Cool, lovely. Keep going.
And then I said y equals, I simplified it. I said 2x to the power of 3 over 2.
Lovely.
Minus 1 plus 5x to the power of negative a half.
Stunning, 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 stunning. Go for it.
And then my answer was y notation x equals 3x to the power of a half And then the 1 is a constant, so it becomes 0. Then I said minus 5 over 2 x to a power of negative 3 over 2.
Wow. That was stunning. Well done, Natalie. Beautiful work.
Thank you,
Beautiful
ma'am.
work. Thank you. Your explanation was absolutely stunning. I could not have done that any better. All right. Yeah, that was really, really good. Well done. Very, very nice. Okay, so Natalie split it up perfectly. All right. Then she got her variables into the numerator. So all of that was done perfectly, and then applied her power rule like so. Okay, very good, Natalie. Good job. We will definitely want to see all of you can do this. Okay, well done, Natalie. I'm so glad that you tried this, and we got to hear that beautiful voice of yours. Deandre, you want to ask a question?
Yes, ma'am.
Go
For
for
the
it.
previous question, it is 1 over t.
Yes.
So I wanted to know, why does it become t to exponent negative 1? Is 1 minus 1 not 0?
Okay, so when you take for example, let's say if you've got 1 over x squared and you want to write that x squared in the numerator, you would do that. You would change the sign of the exponent.
Okay.
Does that ring a bell to you?
It does, but it's still confusing because the t at the bottom does not have a square.
So it's to the power of 1 at the bottom, that's why.
Yes.
Okay, so you've got 1 over t to the power of 1. So when you write it in the numerator, it would be t to the power of negative 1. So this exponent over here is what changes its sign.
Oh, okay. And then it's times 1,
Okay.
which
Yes,
makes it
and then it
remain the
would be
same.
exactly.
Okay, ma'am. Thank you.
Okay, no problem. No problem. Got it. There we go. Okay. All right, lovely. So now we've got a few minutes left. Let's talk about binomial denominators. So we've spoken about monomial denominators and how we split it up. And let's talk about binomial denominators. And hopefully we've dotted the I's and crossed the T's, so to speak. Okay, so when it comes to binomial denominators, the way we answer the question is a little bit different. Okay, we cannot split it up because it has a binomial denominator. So what we would do in a situation like this is we are going to factorize. And after we have factorized, it means we are allowed to cancel something at the top with something at the bottom. And then once we have simplified what we've got, we can apply our power rule. So let me show you what I mean by this example. Let's just move those ones out the way and go back up to this guy. Okay, so if you have a look at the numerator, it's a cubic, but there's an x in every single term, which means that you would be able to take out x as the highest common factor first of all. So we would do that to the numerator. That would give us 3x squared minus 7x minus 6. At the bottom, I don't want it as 3 minus x. I want it as x something 3. So I want to take out a factor of negative 1 at the bottom. And then I can write that as x minus 3. Okay, if you do that in the first step or in the second step, it doesn't matter. Keeping my dx, keeping my square brackets, I'm now going to factorize the numerator, sorry, the trinomial in the numerator. So I'm going to have 3x in one bracket, x in another bracket. I've got my minus x times minus x times minus 3 at the bottom, close my square brackets. And now I'm going to factorize this trinomial. So I'm going to put 3 over here. I'm going to put 2 over there. I want negative 9 plus 2x to give me the minus 7x in the middle. And positive 2 times negative 3 will give me my negative 6. Now that I have factorized, I can cancel down. So I can divide x minus 3 with x minus 3, and I can simplify what's left over. Okay, so remember my numerator is now being divided by -1. So that gives me -x into 3x plus 2. Get rid of my brackets. So that will give me, let's just go down a little bit, -3x squared minus 2x. And now I'm ready to apply my power rule. Okay, so my final answer, dropping my dx, dropping my square bracket, I would end up with -6x minus 2, like follows. Okay, any questions, Matrix?
Ma'am, why can't you factorize from the get-go there at the start where
You can.
3 to the power of 4?
So just say that again, please. Why can't you factorize?
From the get-go, there at the top.
I did. So I first took out a common factor and then I factorized the trinomial. Are you saying can you do that in one step?
Like, can you do it without taking out x first?
No, no. You always have to take out a highest common factor first.
Okay, ma'am. Thank you.
Okay, no problem. Any other questions?
Nice, my people.
Okay, all right, cool. All right, so here are 2 questions for you to try, Matrix. I think we're only going to have time for one. I see we're already running out of time and just goes by so fast.
And we
Okay.
need to do a poll. Don't log out. Please don't log
Okay.
out.
All right, so try either one of these 2. We'll quickly do the answer, the poll, and then we can say goodbye. And again, when you're done, just put the word done into the chat, and then at least it gives us an idea of where you guys are at.
Ma'am, I have a question.
Sure, Hillary, go for it.
In an exam,
Yeah.
how do you know if they want you to find the x value or they don't want you to find an x value?
Okay, so if they want you to find an x value, then they'll tell you to solve for x.
Ma'am, like
Or
sometimes there was like I met up with this question in the exam where there were a couple of x's inside the question, and they didn't specify that, they didn't say that they wanted x. I think they said they wanted a root or something, but then in order for me to find the root, I had to find the x value.
Okay. Hillary, I would have to see the context of the question. If you want to, you can email. Do you have the question?
I can look for it, ma'am.
Okay, so tell you what, here's my email address. Are you doing the boot camp? Hillary?
Yeah, ma'am.
Are you doing boot camp?
Yes, ma'am.
Oh, okay. All right, cool. So tell you what, email the question to me. All right, here's my email address in pink. All right. And then what I can do is I can address it either at boot camp or at our next lesson if you send it before then. Okay.
Yes, ma'am. Thank you.
All right, cool.
Sorry, Teacher Lee, it looks like they are leaving, so I'm just running the poll while we're busy
Go for
finishing
it.
this.
Okay, that's
So
fine.
that I
I'll
can
just put
give everybody.
that's fine. I'll just put up the answer in the meantime.
Thank you.
Okay, and then let's just do this one quickly as well.
Ma'am, do I get penalized if I don't put a DP or DX?
You will, yeah, you will, you will, absolutely. So that's why I don't know if you've noticed, but the whole way through our lessons, I've tried to emphasize the notation as well as what you are writing. Okay, they will penalize you, yes, and you'll get penalized at the end of the year when you write your exams. Okay, there's normally 1 penalty mark for notation. And then they also penalize you on first principles if you drop your limit notation too soon, or if you show that h is equal to 0. So yeah, you've got to be very, very careful. All right, so you've got to keep your original notation until the line in which you apply your derivative. Okay. All right, so then you'd end up with that after you factorized. And then this means you would end up with minus x minus 3. And now you can drop your dx in your square bracket and your final answer would have been -1. That's it. There we go.
Nice, guys. I just want to make it clear
Alright.
that let's not share any personal information because of this POP acts that they're putting in South Africa, and also for your own safety. I mean, we trust all of you, but just for your protection, and also because of this rule that South Africa has put, we cannot share our personal information on the charts. Okay.
Yeah. No, certainly not, unfortunately.
Okay, let's vote. We are getting there. I'm interested on my poll. Let's get the poll done, guys. Night
Please answer the
shift.
poll, and then if you've got
Yes,
any
please.
questions, you can ask. You
I got
too,
my
Trish.
100%.
Thank
Hello,
you.
ma'am. Hello, ma'am.
Hello, Tsegofatso.
Yes, can I ask, are we going to do cubic roots for the exams? In
Yes,
the class?
absolutely. Yes, absolutely. So our next 2 lessons are going to be on factorizing cubic expressions and solving cubic equations. And then we're going to move into the cubic function.
Okay.
Okay.
Thank you.
Pleasure, no problem. Katleho, did you want to ask a question?
Ma'am, I just wanted to ask if you have extra questions so that I could practice, ma'am, because
Yes.
previous question papers, I do not see these kind of questions, or maybe I'm just not looking.
Okay, so yes, these sorts of questions are in the question paper. It's your second question after they've asked you to do first principles. That's what we're doing at the moment, okay, is differentiation by rules. Okay, so here I've got some practice questions for you. You can try this one, and then there's a nice difficult one there as well, BB, that you can try. Okay. So anybody interested in a bit of extra work? Those 3 questions on screen. Okay, it's a pleasure.